आज सॉल्व करेंगे लीड कोड 53 and let's make it a little dark ना ऐसा होएगा। अब अच्छा है। लीड कोड 53 प्रॉब्लम का नाम है मैक्सिमम सब अरे प्रॉब्लम स्टेटमेंट क्या कहती है? टू फाइंड सम ऑफ contiguous सब अरे with maximum sum maximum continuous array with maximum sum. That makes sense. Okay, so हमारे पास कोई भी रैंडम एरे दे रखी है, let it be -4 -3, let's say the 5, let's say 1, let's say -2, let's say 6. You have to find a subarray which will return maximum sum and it has to be contiguous. Contiguous मतलब कि एक के बाद होना चाहिए. We cannot miss anything in the middle. We cannot be like 5 1 -2 ऐसे हम ले लेते हैं, -2 को निकाल देते हैं, let it be that answer with the 12. That's not what contiguous means. We have to use continuous elements. So अगर हम इस array को देखें तो we know if we do 5 plus 1 plus -2 plus 6, which is index I is equal to 2 say I is equal to 5, we will get the maximum sum, which would be 6 minus 2 4 be 10, right? Now we have to implement this in program. So how do we actually do it? We use Kadane's algorithm. Kadane's algorithm, what does this algorithm says? This algorithm says कि we will start from the beginning. Single loop में कर देते हैं instead of using two loops. We will start from the beginning. We will maintain some of the elements which have been traced till now. अगर वो sum maximum है to variable maximum जो हमने पहले से maintain कर रखा है, then maximum sum will be that sum. So for example, let's say if हमारे पास, जैसे हम इसको लेते हैं, ट्राई रन करते हैं, -4 -3 5 1 -2 एंड 6. हमने -4 लिया, फिर ये है i इज इक्वल टू 1 पे. अब हमने i इज इक्वल टू 0 पे हमने मतलब एक लूप चलाया. ओके, लूप स्टार्ट हुआ हमारा i इज इक्वल टू 0. ओके, i इज इक्वल टू 0 पे हमने फर्स्ट एलिमेंट लेंगे, कंसिडर करेंगे -4. सो एलिमेंट इज -4, current sum will be -4, max sum till here will also be -4. अब हम आएंगे I is equal to 1 पे, current element is -3. तो अगर हम -4 प्लस -3 करें तो sum will be -7, right? -4 प्लस -3 will give -7. बट अगर हम -7 को लें, -3 को देखें तो दिस इज़ नॉट हेल्पिंग अस, राइट? तो अगर हम यहाँ पे करंट सम ले लेते हैं, करंट सम भी -7, राइट? एंड अब हम मैक्स सम देखें, अगर हम मैक्स सम देखें, इट विल बी बिटवीन -4 एंड -7. तो इट विल डेफिनेटली गो विद माइनस. बट यहाँ पे अगर हम देखें -4 एंड -3 में, minus 3 is bigger, so we'll make current sum, we'll use we'll use current sum as minus 3. So now second उसमें okay, थोड़ा सा confusion हो गया, मैं भी थोड़ा confused हो गया. Let's do it from the beginning. Okay, what does Kadane's algorithm says? Kadane's algorithm says कि we have to decide if we have to keep the current element, or or should we ignore it, or which means कि if that element helps us in a maximum sum, then we'll keep that element. If it doesn't, then there is no point of keeping it, right? So how it works is, how this algorithm works, let's do it through a do it through a dry run on this, so in this on this subarray. So when our on our first iteration, when I is equal to 0, our first element is minus 4. Here, okay, let's make a table better, right? Here we have I, here we have element, here we have current sum, here we have max sum. अगर हमने एलिमेंट लिया I इज इक्वल टू 0 पे, राइट, I इज इक्वल टू 0 पे एलिमेंट आया माइनस 4. ना करंट सम देखना है हमें. करंट सम हमारे पास में अभी तक हमने करंट सम लेट्स से हमने ले रखा है माइनस 4 ही ले रखा है. सो लेट्स सी. Okay, how to choose a default current sum, that is also uh, that also includes a very good concept, like which you can keep in mind whenever you're trying to run through a problem, when you're trying to find a solution of a problem where you have to compare elements. Like if you have to compare all the elements, then it's better to use that strategy. If you have negative elements in the array, let's say if you have negative elements in array, always use current sum or maximum sum, whatever your default variables which we are going to use to capture the result. Always initialize that with with first element of the array. If you don't, if you don't, then always initialize those variables, some variables, as 0. Okay, not array 0, 0, always 0. Okay, that helps. That keeps, because negative elements may, if we use 0, then it's a good chance we might end up losing some elements. For example, let's say we have an array having all negative numbers, your answer will be 0, which does not make sense, right? It does not make sense. It's better to use the first element as the base and then use that as a reference uh, for other elements in the array. So here keep this as a star. This is a very good, you know, concept, which it's not an algorithm, it's not provided somewhere, it's just an observation which I have figured out after like years of using solving problems. So yeah, now we will do dry run of minus 4. We'll use a table, so let's use a table. And let's use a table here. Table here we have minus 4 minus 3, then what we have, uh, 5 1 minus 2 6, 5 minus 6, yeah, we have 5 1 minus 2 and 6. So I element current sum and max sum. I is equal to 0, current element is 4, since we are going to use the same concept, our current sum will still be 4 and max sum will be still be 4, right? Now for I is equal to 1, current element will be minus 3. Current sum, we have to compare this number with the sum of the element. So we'll compare minus 4 with minus 3 plus minus 4, so which is minus 4 minus 7. so यहाँ से करंट सम बड़ा कौन सा है, माइनस 4 बड़ा है, राइट? सो माय बैड, यहाँ पे थोड़ा सा it's not minus 4, it should be, you have to compare current element not previous element, should be minus 3, right? Minus 3. So now minus 3 and minus 7 में बड़ा कौन सा है, minus 3. So current sum will be minus 3. Now we will compare max sum with the current sum. So max sum is minus 4, current sum is minus 3. So max sum will become minus 3. Now I is equal to 2 पे current element is 5. So now we'll compare 5 with 5 plus minus 3, which is current sum. It will become 5 comma 2. Our current sum will be 5. Now we will compare 5 with minus 3. Current max sum will be 5. Now I is equal to 3 पे current sum will be 1. It will be 1 comma 5 plus 1, which is 6. And now we'll compare 5 and 6. 5, this is the 5, this is the 6. So our element will become 6. Then we have 4 and we'll use minus 2 now, minus 2, and it will now check 6 comma minus 2, 6 comma 6 comma sorry, it's not 6, it should be minus 2. Current element is minus 2, my bad. So it will be minus 2 comma 6 plus minus 2, right? And so which it will become obviously 4. So now here we'll compare which is going to be bigger. Is it going to be 6 or 4? 6 is bigger, so we'll use 6 as the maximum sum. Am I doing a mistake somewhere? I feel like I'm doing a mistake somewhere. We'll see. Now this is 6 where we have element 6. Now we will compare 4 comma 10. It will be 10. And now we'll compare 6 comma 10. Our answer will be 10, right? Here we have 10. So this is current sum. This is our answer. So max sum will be 10. Easy, right? So now we'll make this, now we'll write a code for this. What we have to do, we have to public int max sum subarray int array, right? Int n is equal to array dot length, int max sum is equal to array 0, and current sum is equal to array 0 for int I is equal to 1, because 0 we already have traverse, right? So we don't need this. I is less than n, I plus 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 plus. Current sum will be math dot max of current sum comma current sum plus array I, and maxsum will be math dot max of current sum comma max sum, right? And we'll do return max sum. Done.